So this section here, this is where I start really liking this chapter more. And because it involves the stuff we just were doing, finding areas, but then it takes it and combines it with the stuff from the last chapter where we have 3D objects. We need to take and unfold the 3D objects to make like a net or that type of stuff. So I think you'll enjoy it. First thing we need to do is a couple of terms. So polyhedron, I want to say two things about polyhedrons. One, they're three-dimensional objects. Can I just do 3D like that? And instead of, you could write out three-dimensional, D-I-M-E-N-S-I-O-N-A-L. So they're 3D. And each face is really just the fancy word for side, is a polygon. So if you have like a north face coat or shirt or something like that, talking about the north side of the mountain, the north face. But so each side here, you'll notice some of them are shaded, but each of these are polygons, so that would be a face there in blue, this would be a separate face in red, this would be a face over here on that side, but each of those are going to be faces. Fair enough? Cool. A vertex is just kind of the sloppy definition would be like a corner, so kind of the point. So not an edge, but just like the corner pieces. Each of those would be a vertex. So it's a corner. And plural for vertex would be?
Vertices.
Vertices, nice. So if they talk about vertices, it just means more than one corner, more than one vertex. All right. Surface area. Area is a capital A. A wise person would guess surface area is just SA. So I'm going to start doing capital S, capital A for surface area. And if we want to get the surface area of one of these polyhedron, three-dimensional objects with these flat sides, it's going to be, well, you take the area of this side, the area of that side, the area of this side, the area of all the different sides, and add them together. Perfect. So we could say something like the sum equals the sum. Math word for total. The areas of the sides. And getting close to the end of the definitions, because they tend to be a bit laborsome, I think. But a prism, we're going to look at equations for prisms and equations for pyramids and that type of stuff. But whenever they talk about a prism, you have to have one of these polyhedrons, a three-dimensional object with sides, each face, is going to be a polygon. But it has to have, if you notice, each of these in the picture has two sides that are in blue. And the two sides that are in blue are congruent, which means they're identical to each other, and they're P-word? Parallel. So they're not on an angle compared to each other. So they're either both horizontal or both vertical or both on this certain angle, whatever angle this would be on. Or maybe that's vertical, actually. These would be on a weird angle. But moving on. Okay, so get rid of those. So a polyhedron with two congruent. So with two congruent. Or you could do the symbol if you wanted to. Parallel faces. Or congruent, maybe I'll say the same. Or identical, parallel faces. And pyramids will often have more than one side that are congruent to each other, more than one face that's congruent, but they won't be parallel, so then they're not a prism. And so all these things down here are all going to be prisms. Feel like you kind of have a general idea for a prism? And
what is it called, a triangular prism?
Yep, so yeah, that first one would be a triangular prism, and you could go and name them that way, because the bases are triangles. Or pentagonal prisms, you have pentagons, rectangular prisms, and so on. So a net is just going to be an unfolded 3D object, so unfolded. Ooh, spelled that one wrong. Unfolded, three-dimensional or 3D object. And instead of having to do a couple of my bad drawings, just tried putting some in here. So we have this one here. If you take and cut it here and here and there and there and there, you could take and kind of fold these edges out, fold the triangles down, and you get this here. So we want to use these nets. If we're looking for the total surface area, we could take and unfold the object into something like this, then find the area of each of those chunks, add it together, which we're going to do on the next page. And shazam, you're done, you have the surface area. So same thing here, if you have a box like this, you could unfold it. And like we did in the last chapter, if you could be careful when you do your net, like this side here matches up with this brown side. So you want to have those be the same length as each other. Or you could say maybe the blue side here is going to match up with this red side here. So if you can draw them kind of to scale, it's going to be easier to not get confused. It's the people that are kind of sloppy and try to skip steps and do too much at a time. They're the ones that start struggling in this section. The people that kind of lay out their work nicely, they're the ones that typically do better. That's kind of why I've been trying to hound you to write the equation, put in the numbers. Because if you're organized like that, it's going to be easier. All right, so if we have a cylinder, looking at this object there, if we take and cut it right here, and then fold this out, and lay the circles flat, it's going to give you this here for a net. We good? And this will come up more on the next page, but what I'm trying to get at is this. We'll need to know the length of this side here in red, and often they won't give it to us. How could we find the length of that side knowing what we know? John? That he's right on. That red thing, if you were to take and wrap it around the circle, you can kind of picture like folding that circle back up the base like it was here. The base of that circle is going to be, or the circumference of the circle is going to be the same as the length of the red line. Fair enough? That's real common that people get stuck on that, so I'm maybe going to write it down. You could write it, not write it, but you could say, how do I make that short? I guess even do a picture and just say base equals circumference of the circle. Something like that. Or base of the rectangle, the base of the side, equals the circumference of the circle. But that's something that I found a lot of people would get stuck on last year. Ready to flip the page, do a couple examples? All right, let's knock this out. All right, so finding surface area. So find the area of each part and add them together. That's what we said was the key over on the first page. So maybe let's start with this. And you could go through and I can easily color code things in mine. Sometimes I'll go through and instead I'll, in my notes, say like, okay, so A1, and call this, all right, this is going to be my first area. But that shape there is a rectangle. And if you're not sure, just go with base times height, because that'll work for squares and for rectangles. But the base is going to be 30, agreed? Because top and bottom both are 30. So we have 30. And I could do units. I'm going to bail on units, I think, for right now. So 30 times 24. Let me grab a calculator. That gives me 20, 40, 60, 72, 720. So 720. And maybe I'll put in units here. Can I convince you it's square centimeters? We should have done the 30 centimeters times 24 centimeters and all that. But now, what do you notice about this object in that area?
It's the same as the middle.
Yeah, perfect. Perfect. So that's, if we figure that all out, it's going to have the same dimensions. So do you agree we can just double this and say those two together are 1440? Fair enough? Cool. Then, if we would, should we do this skinny section here in the middle next? And that's where you could even, if you wanted to be organized, go through and, I jumped the gun there. Wasn't going to admit that quite yet. But, all right, so if we do the second one, maybe call it area 2. So my second area is going to be a rectangle, so it's base times height again. What does the base have to be?
30. It has to be 24. No, 5.
Well, one of
It
us...
says 5 over there, but the length
5, yep, because if this is 5, well then this folds together with it, so that's 5. And if it's a rectangle, then this side here is going to be 5, and that folds with this, so that side's 5. So do people see base is going to be 5 centimeters? Mm-hmm. And our height is 24, because this side's 24, so then this side would be 24. And 5 times 24 would give us 95? No, 120. 120.
And then you can times it by 4 because it's 44 little times.
Do we multiply it by 4 or a different number? 2. It's tempting to go by 4, but this one here has a height of 24. What's this side here? What's that length going to be? That's going to be the 30, because that gets paired up with this guy. So I'm going to leave my 24. But we can multiply that by 2 and then get those 2 that are in red. So we have 240 square centimeters there. But now we have to do a different calculation for these two. And yep, 5 and 30, because we'd have 30 there. And again, the height's 5 on that. So area equals base times height. And we put a 30 in for the base, a 5 for the height. So 150. We multiply that by 2. So each one is 150 square centimeters. There's 2 of them for a total of 300 square centimeters. And now to get our final answer, we just take and add all of those together. So if you beat me to it, feel free to holler the number out. That's
1,980.
perfect. Thanks, John. So 1,980. And the units will be?
Centimeters squared.
Perfect. Centimeters squared.
Hold on.
I wasn't getting a lot of deer in the headlights looks, but any questions? If so, you're probably not the only one. If I confused you, I probably confused some others. All right, then let's jump to our last one. The last one will be a little shorter. And so this one here, we really only have 3 sections we need to find. You want to start with a circle or the rectangle?
Circle.
All right, so we'll start with a circle. So, at least one part of the circle you have to start with. So area of that is going to be pi r squared. Agreed? And the 4 is the radius. We don't have to cut it in half or anything. So we end up with pi times 16, or pi times 4 squared. So if I punch that in, I get 50.3, 50.27. I'll maybe say 50.3. But we take that and multiply it by 2. So it's that many square inches. But when I double it, I get 100.6 square inches. What probably would have been smarter is to just, in my calculator, do times 2. And then I don't have that rounding. Because if I multiply by 2 here, my rounding just got twice as big. So it technically should be 100.53. But should we leave it at 100.6 or change to 100.5? All right, we're leaving it. Makes me a little sad. Okay, so we have that. So we have our 2 circles taken care of. Now, our next shape's a rectangle. So we do area equals base times height. And the 6 is the height. So we put that in for h. The base is...
Don't you have to find the circumference?
Perfect. Yep, base is the circumference because this length here is going to wrap around my circle. So if we figure out the circumference of the circle. So C equals, we could say pi times diameter, or we could say C equals 2 pi r. Which one's easiest?
2 pi.
Perfect, because we know the 4. Or you could just in your head say diameter's 8, radius is 4. And either way we get 8 times pi, which is 25.1. So 25, yeah, you could do the 25.13. And then I'm going to just do my answer times 6 so it doesn't round at all. And so 150.8. So 150.8, that's inches squared, or square inches. Do we double it?
No.
Nope, because there's just one of those rectangles. And last step then is to add those 2 together, my 100.6 and my 150. So we get 251.4 square inches. So 251.4. Work for you? So I kind of enjoy it, but like normal, I'm looking for when you do the area stuff, write out the equations, then put the numbers in, then get the answer. I know for some of you it's like, but it doesn't take long. You're more likely to get it right.